The stria terminalis, or terminal stria, is a structure in the brain consisting of a band of fibers running along the lateral margin of the ventricular surface of the thalamus. Serving as a major output pathway of the amygdala, the stria terminalis runs from its centromedial division to the ventromedial nucleus of the hypothalamus. Anatomy. The stria terminalis covers the superior thalamus striate vein, marking a line of separation between the thalamus and the caudate nucleus as seen upon gross dissection of the ventricles of the brain, viewed from the superior aspect. The stria terminalis extends from the region of the interventricular foramina to the temporal horn of the lateral ventricle, carrying fibers from the amygdala to the septal nuclei, hypothalamic, and thalamic areas of the brain. It also carries fibers projecting from these areas back to the amygdala. Functions. The activity of the bed nucleus of the stria terminalis correlates with anxiety in response to threat monitoring. It is thought to act as a relay site within the hypothalamic pituitary adrenal axis and regulate its activity in response to acute stress. However, the stress response is time-related and the BNST does not activate for contextual fear. This means that a sudden scary situation that is under 10 minutes long does not activate the BNST. It is also thought to promote behavioral inhibition in response to unfamiliar individuals, by input from the orbitofrontal cortex. Bilateral disruption of this pathway has been shown to attenuate reinstatement of drug-seeking behavior in rodents. Bed nucleus of the stria terminalis. The central subdivision of the bed nucleus of the stria terminalis, BSTC, is sexually dimorphic. On average, the BSTC is twice as large in men as in women and contains twice the number of somatostatin neurons. A sample of 6 male to female transsexuals taking estrogen were found to have female typical number of cells in the BSTC, whereas a female to male transsexual taking testosterone was found to have a male typical number. The authors, W. Chung, G. De Vries, Dick Swab, also examined subjects with hormone-related disorders and found no pattern between those disorders and the BSTC, while the single untreated male-to-female transsexual had a female typical number of cells. They concluded that the BSTC provides evidence for a neurobiological basis of gender identity disorder and proposed that such was determined before birth. Since somatostatin-expressing neurons typically block dendritic inputs to the postsynaptic neuron, thus inhibiting signals traveling through associated structures, it is believed that the larger bed nucleus of the stria terminalis found in men, including transgender men, reduce the startle response in men and may be responsible for the higher incidence of specific phobias in women, and a possible source for the stereotype of women being afraid of mice. Criticisms of the former statement suggest the study used an unrepresentative sample and did not adequately control for hormone replacement therapy, which has been shown to influence hypothalamic size, even though the study tried to do this by including non-transsexual male and female controls which, for a variety of medical reasons, had experienced hormone reversal. The statement about the neurobiological basis from birth has later been brought to question, though not refuted, by a follow-up study by the same group which found that the sexual dimorphism of the BSTC is not present before adulthood, approximately 22 years of age, even though transsexuals report being aware of their gender identity since childhood. Oxytocin receptor activity in the BNST is important for social recognition in rats. Both male and female rats that received a microinjection of oxytocin receptor antagonist had lower social recognition scores than rats that received a vehicle injection, and microinjections of oxytocin into the BNST enhanced social memory in male, but not female, rats. Reduction of the size of the bed nucleus of the stria terminalis has been observed in pedophilic male perpetrators, in addition to reductions in the right amygdala, hypothalamus, and abnormalities in related structures. The authors propose that childhood deficits in the BNST and medial amygdala may cause inhibition of sexual maturity.
Please subscribe and thanks for watching.